Continuing our course on automation, coding, and traffic, today's lesson is dedicated to text generation, and by the end of it, you will further deepen your knowledge in the field of automation. Today we will create a prompt builder based on Google Sheets, which will allow us to mass-produce prompts in one click based on our keywords. Then we'll create the basis of our Pinterest monster and connect it to the prompt builder through the Google Sheets API. After that, we'll teach your bot to mass-generate titles and descriptions for our pins using ChatGPT and save the results in a table for later uploading. Let's start our lesson with the creation of the prompt builder. Let's start by creating a table in Google Sheets and name it Pinterest. Next, create 3 tabs: Prompt Builder, Video Prompts, and Image Prompts. In the first tab, create columns with the following names. In the first column, we will insert our keywords. In the second column, we'll have our raw title prompt. It will look like this. Paste the prompt into the second cell of the second column. Now, we need to spread this value across the entire column. To do this, select the starting cell of the range, then use the keyboard shortcut Ctrl-Shift and down arrow. After selecting the entire range, paste the necessary value using the standard Ctrl-V command. To create the final prompt, we need to write a formula that will replace the phrase selected keyword in the cells of the second column with the keywords from the corresponding cells in the first column. We will use the substitute function for this. Enter the following formula into the second cell of the column with the final prompt and drag it down to apply it to the entire column. Now insert the keywords into the first column and see what we get. If you later modify the prompt, don't forget to stretch it across the entire column again to replace the previous values. Now let's create a prompt for the description following the same approach. The raw prompt will be as follows. Paste it into the starting cell of the fourth column and drag it down to fill the entire column. In the final description prompt, we'll replace selected keyword phrase with the value from the cell in the first column, and we'll leave selected title as is. Later, we'll replace it in the code with the title generated. So paste the formula into the starting cell of this column and drag it down to fill the entire column. Alright, we just need to create a prompt for the tips that will be used for generating images. The raw prompt for this will be like this. Paste it into the starting cell of this column and drag it down to fill the entire column. The formula for the final prompt for tips will be as follows. Paste it into the starting cell of the last column and stretch it down to fill the entire column. Okay, our prompt builder is ready. Now let's move to the Video Prompts tab and create a dataset for the bot. Let's create columns with these names. Now we need to fetch the values of these columns from the Prompt Builder tab. To do this, we will use the array formula function. Here we refer to the range of cells in the Prompt Builder sheet in column A starting from the second row. Insert this formula into the starting cell of the first column, and the data will be automatically pulled in. Now let's do the same operation for the next column, fetching data from the final title prompt column in our Prompt Builder. We'll do the same for the third column. Now let's move to the Image Prompts tab and do the same thing, only adding another column. Tips prompts. We're almost done with our prompt builder. We just need to fix one thing. If we scroll down, we'll see that the columns with prompts continue even after the keywords end. To fix this, we need to add a check for non-empty cells in column A to the formulas on the Prompt Builder tab. To do this, we'll add the if and is blank functions to our formulas. The modified formula for the final title prompt will now look like this. Add this formula to the starting cell of the column and drag it down. Let's do the same for the columns with other prompts. Now, in the tabs with ready prompts, we can see that the columns with prompts end together with a list of keywords, which is what we wanted. With this, the development of our prompt builder is complete. So, let's start developing our Pinterest monster. First, create a new project in PyCharm and name it Pinterest Monster. Our bot will consist of three main modules: Writer, Image Generator, and Pinner. Today, we'll write the first module, Writer. We'll develop the core of the bot according to the following plan. Now let's go back to our project and create a file named main.py, which will serve as the entry point for our application. Then create a package named modules, where the classes of our bot will be located. We'll extract common elements of our classes into a separate base class using the inheritance mechanism. So, let's create a file named base.py for the parent class and declare the Pinterest class in it. For our writer, create a file named writer.py and declare the writer class in it, inheriting from the base Pinterest class. So at this stage, the class structure of our project looks like this: the parent class Pinterest and the child class writer. In the following lessons, we'll add two more classes for the image generator and Pinner, inheriting them as well from the parent Pinterest class. Now, let's think about the methods that should be in our bot. To make our writer do its job, we need to open and read the file with prompts, write the text, and save the result in a file. To write the text, let's create a public method right in the writer class. Methods for opening and writing data to a file will be needed not only in the writer class, but also in other bot classes that we'll write in the following lessons. These methods are common elements for several classes. Therefore, let's declare these methods in the base class. Now let's create the folder structure for our bot. Create a folder named Projects, inside which there will be folders for our projects. For example, create a folder named Keto. Inside each such folder, we'll have the results of the writer, generator, and tables for the generator and Pinner. Let's create the path to the project's working folder and specify its automatic creation. So the project folder is a common element for several classes, and we'll move this element to the base class. Let's create a constructor of the class using the init method, inside of which we'll create an attribute called project path. Then, we'll form the path using the join method and assign this value to the attribute. We'll also accept an argument with the project folder name in the class constructor. After initializing the attribute, we'll add automatic folder creation at the specified path using the makeDirs method. Now let's go to the child class writer and also create a constructor for the class. We'll accept an argument with the project folder name, then call the constructor of the parent class using the super function and pass this argument. Now let's go to the main.py file and write the launch logic for our writer. Let's start by creating the writing function. Inside this function, we'll create an instance of the writer class and assign it to the variable writer. We'll accept an argument with the project's working folder name in the function and pass it to the class constructor when creating the object. Import the class and move the import statement into the function. Now let's declare a variable data and assign it an empty list for now. We'll add data opening processing later. Then let's create a for loop, inside of which, for each row, we'll call the write method through our writer object. Now let's create an entry point using the if name statement, inside of which we'll declare a variable project name and assign it the name of the project's working folder. Then we'll call the writing function and pass this variable as an argument. With this, the basis of the byte is complete, and we can move on to developing our writer. So let's start by installing the necessary dependencies. We'll need two libraries for our work, GPT for free and gspread. Install them through the terminal using this command. Now let's proceed with implementing the data reading method. So our source data comes from the video prompts and image prompts tables. To read data from them, we need to export CSV files of these tables, give them appropriate names, and place them in the prompts folder of our project. Then, depending on the mode passed to the method as an argument, we need to open the corresponding file, read the data from it, iterate through the rows in a loop, add the values of each cell to a separate dictionary, and then return a list of these dictionaries. This way, each row of the table will represent a separate dictionary in this list, and the contents of the cells will be the values of the keys in this dictionary. To save time on exporting, renaming, and moving prompt files to the project folder, we will also add the ability for the bot to connect directly to our Google Sheets table through the API. Let's start implementing this. To start, let's go to the base class and declare class attributes, assigning them string values of the file names needed for our work. Then in the class constructor, create object attributes representing paths to the prompts and data folders formed using the OS module. After that, use the MacAdeers method to ensure the creation of the necessary folders at the specified path. Also add two methods for logging errors and messages. Now let's move to the writer class. To implement both methods of reading data, let's create another method called openData. In this method, accept these parameters and set default values. In the method, add a check. If the value of the Google Sheet argument is true, we will read data from tables via API. Otherwise, we will read data from a CSV file. In the second part of the check, set the necessary file name depending on the mode. In the if and elif blocks, we assign the value of the required attribute taken from the base class to the variable file name. In the else block, we raise an exception if an incorrect mode is passed. Then call the openCSV method from the base class and pass the variable with the file name as an argument. Save the result in the data variable. We'll implement the openCSV method later. For now, simply return the variable with data from the openData method. Now let's implement the first part of the check. For connecting to the Google Sheets, we need to go to the Google Cloud Console, create a new project or select an existing one. Enable the Google Sheets API and Google Drive API, create and download a JSON key file, and open access to the tables. Let's go through these steps. Go to the Google Cloud Console. Create a new project or select an existing one. Then go to the API and Services section. Find and then enable the Google Sheets API and Google Drive API. Click on Create Credentials and create a service account. Then go to Credentials and click on Manage Service Accounts. In the Actions section for the service account, choose Manage Keys and create a new JSON key. Download the key and create a data folder in our Pinterest monster, then move the downloaded key into that folder. Rename the file to keyfile.json. Open the key file. Copy the client email from there. Now, open the prompt builder table and add this client email to the list of table users with the necessary access rights. Now let's go back to the code and implement the first part of the check. To connect to Google Sheets, we will create a separate method called getGoogleCreds, where we will form the path to the JSON file, set the scope, and return credentials from the method. In the OpenData method, we will call this method and save the result in the creds variable. Then we will perform authentication and connect to the table using the identifier, which we will later pass to the method as an argument. Now we will select the necessary worksheet based on the mode. Sheet numbering starts from 0. Next, we will get all values from the sheet and save them in the allValues variable. To create a list of dictionaries, we will create a separate method called parseRows, which will take a list of data and the mode as arguments. In the method, we will initialize an empty list, then iterate over the data in a loop. For each row, a dictionary row dict is created with these keys, and the values are taken from the corresponding indexes of the list. On each iteration, we add the row dict dictionary to the data list and return a list from the method. Now, we will call this method in the OpenData method and save the result in the data variable. Let's test the bot's functionality at this stage. In the main PI file, in the writing function, let's declare a variable and assign it the identifier of the table. You can find this identifier in the URL of our table. Now let's call the OpenData method and pass the necessary arguments. In the loop, we will print each row to the screen. We also need to accept an argument with the writer's mode in the function and pass it to the function from the entry point. Let's run the bot and see what we get. Great, the data is being read and packed into dictionaries. The only thing to fix is not to add the first row containing headers to the list. To achieve this, in the parseRows method, we'll use enumerate to get the index. Then we'll use the continue statement to skip the first iteration of the loop. Okay, now let's handle the possibility of reading data from CSV files instead of connecting to Google Sheets via API. To do this, we need to implement the OpenCSV method in the base class. Alright, let's first add the file name parameter to the method. Then we'll create the full path to the file. We'll create a separate method for this because a similar code block will be needed later in the method for writing data. Now let's check if the file exists and raise an exception if it's not found. Next, we'll determine the delimiter of the CSV file by creating a separate method. After that, we'll initialize an empty list to save the results. Open the file, skip the first line with headers, create a CSV reader object, and iterate through the CSV file in a loop. For each row, we'll create a dictionary with the necessary keys and values taken from the corresponding indices. Then, we'll add the dictionary to the results list and return a list of dictionaries from the method. The method is ready. Now let's export the prompts file from the Google Sheet. Rename it and place it in the prompts folder. In the main PI file, set the value of the Google Sheet parameter to false and run the bot. Everything works. The logic for reading data is implemented. Now, let's move on to implementing the write method. This method will take a data row and a mode as arguments. The logic of the method will be as follows. If the mode passed to the method is video, we write the title, description, and write the data in the uploading data CSV file. If the mode is image, We write the title, description, and tips, and write the data in the generator data file for subsequent image generation. So to start, let's check that the mode passed to the method is correct. Now we need to create a dictionary for the subsequent writing of data to the CSV file. In the uploading data file, we will need columns with such data. So let's initialize the dictionary and set default values for some of this data. Now let's open the try block and add a new key value pair to the dictionary. We'll use the key keyword and add the keyword extracted using the get method from the dictionary pass to the method. Now let's call the logging method from the base class and log the process of writing the title. Next, we'll retrieve the prompt from the dictionary using the get method and store the result in the variable title prompt. After that, we'll call the method for writing text based on the prompt, which we'll write later, and pass title prompt to it. We'll save the result in the variable title. Then we add a new key value pair to the dictionary. We use the key title and assign it the value obtained from the title writing operation, pre-cleared of quotes, using the strip method. Following the same principle, we'll write and add to the dictionary for the description only in the prompt using the replace method. We'll replace the phrase selected title with the ready-made title. If the title is not obtained, we'll replace it with the keyword. In the same way, we'll write and add tips to the dictionary. Next, let's handle an exception in case an error occurs during the process. After that, we'll determine the file name based on the mode and write the result using the write CSV method called from the base class. We'll implement it a bit later. For now, let's just pass the dictionary with the results and the file name to it. Now, in this class, we just need to write a method for generating text based on the prompt. The implementation of this method will be as follows. Here we create an instance of the chat completion class from GPT for free module and set the model and messages parameters. The model parameter specifies the version of the GPT model to be used, GPT 3.5 Turbo in our case. The messages parameter contains a list of dictionaries, where the dictionary represents a message with its role and content. In the end, we return the generated response. The writer class is written. Now we just need to implement the method for writing the results to a CSV file in the base class. This method will take a dictionary with data and a file name as arguments. First, let's form the path to the file using the method we wrote earlier. Next, define the header for the uploading data. After that, write the header if the file is empty. Define the order of fields for writing. Insert the tips field order for the generator data CSV file. Open the data file for appending and write the data using the dict writer. Finally, log a success message after writing the data. All right, the code is written. We can test the bot now. Before that, let's go to the main PI file, uncomment the method call, and pass the necessary argument there. Before running it, activate reading data from Google Sheets. Also, from time to time, it's necessary to update the GPT for free library, which can be done with the following command. Additionally, we need to make a small change to the write CSV method. To write column headers, we need to check not only if the file is empty, but also if the file exists. So it's better to do these checks like this. All right, now we are ready to run the bot. For the test, let's write prompts for 10 pins. To do this, go to our prompt builder and enter 10 keywords in the first column. Notice how quickly and conveniently our prompts are prepared. Now, we will run the bot, and it will automatically read the data from this tab. Let's finally run the bot. Everything is good. The bot is generating texts and writing them in the table. With this, the development of the writer can be considered complete. Here is your homework for this lesson. You need to set up the prompt builder, connect the bot to it via Google Sheets API, and based on the keywords collected in the second lesson, generate 100 titles and descriptions for pins for each of the 3 offers or niches selected in the first lesson. That's it for now. In the next lesson, we'll continue developing our Pinterest monster and add an image generator to it. See you in the next video.